Okay, we're looking at this problem here where we have 50% of women said they have tried 5 or more diets. The result is true for the current population of women, and we're looking at a random sample of 11 women. We're going to use a binomial probability table to answer these questions. So first thing we can do is we can actually take this and we can figure out the entire table of 11 women. So I want to show you guys that if you go in your calculator stat edit, you can put that in your list. So if you go up to L1, and in L1 you go to second bars for that DISTR distribution, and you go up all the way to binomial PDF, you can type in there your number of trials, which is 11 women, and your probability of success, and close that, and it'll give you each probability of success there. So we can use that to add our probabilities. For at most 7, that would be 7, up to 7 women. And for at least 7, that would be 7 or more women. But for this 4 to 6, we can use this table here. So this is the probability of 0, then 1, 2, 3, 4. So my 4 is 0.16113. And my pen is broken. I have to get a new one. So I'm going to have to write these down. My probability of 5 is 0.22559, and probability of 6 is the same thing. So I'm going to exit out of here, and I'm going to add those together. So for my probability of 4, I had 0.16113. For 5, I had 0.22559, and I had the same thing for 6. So that's giving me this probability here for 0.6123. Now, if I wanted to find a single probability on here, let's say I want to find the probability of 4 women, I would go on here to my second distribution and go up to this binomial PDF, and I do NPX. So an N would be 11 women in the sample. Probability of success is 0.5, and then if I wanted to find 4 women, that's my X. That'll give me that particular probability. Okay, so you can do that for singular probability, or you can always just look at your table and get the probabilities from there. Okay, moving on to the at most 7. So what you're going to want to do here is you're going to want at most 7. So that would be less than or equal to 7. So we're going to use a cumulative probability distribution. So in the cumulative probability distribution, that is going to be up here. We go right underneath the binomial CDF. So again, second distribution, and then up to binomial CDF. Now here you're going to have your 11, then your 0.5, and then we're going up to 7. So this is just going to add all of the probabilities up to 7 for me. And that's going to give me that value there. Okay, now that is at most 7, so that's 0 to 7. That's adding that for me. For C, it says at least 7, so that's 7 or more. So what we're going to do for that one is we're going to want to subtract that from 1. Remember, all of your probability distributions are going to add to 1. Okay, so what we're going to do here is we're going to go 1 minus, because we're doing 7, 8, 9, and 10. You could also just add those together, I guess. Here, oops, go second distribution, go up to your normal, or sorry, binomial CDF, and this would be 11.5, and since you're adding 7, 8, 9, and 10, you're going to do 6 here because it's going to be 1 less. So it's 1 minus the addition of all of these up to 6. We'll give you your probability. What did I do here? I think I forgot a comma. Let's see here. 1 minus second distribution, binomial CDF, 11.5, comma. Yes, I did forget a comma, 6. And that's going to give us our probability for 7, 8, 9, and 10. Again, you could go on your table and you could add those probabilities as well. So those would be right here. Those final 10, It's 11, 10, 9, 8, 7. So you would add all of those together. That would give you the same thing as doing this function here.